Hi everyone, today I'll present our work, SiblingClass TestDetector, finding untested sibling functions. I'm Qian Liang from University of Waterloo, and this work is done with my advisor, Patrick Lam. The goal of work here is to improve test suites by finding of completable or partial completable candidates. We'll explain what these are with an example. Here will be an example of a completable candidates. This chronology example is from an open source benchmark, Joda-time. The bottom level consists of a number of concrete classes, Boolean chronology, GJ chronology, and strict chronology. They all extend the abstract class, assembled chronology. The concrete classes at the bottom level are sibling classes in the class hierarchy. These sibling classes all implement function with zone. It turns out that Joda-time comes with a test suite that tests with zone in Boolean chronology and GJ chronology, but not in strict chronology. Our insight is that by adding this missing test, it will be a potential easy win. Our tool is built to detect completable candidates like this, where a function is implemented in sibling classes but only tested in some. We believe the existing test cases, such as the one covering with zone in Boolean chronology, could serve as a template to help generating unit tests for the untested implementation. The current work detects such situations. On the previous slide, we said the test case that tests with zone. What does that mean? A well-written unit test is ideally testing the behavior of one method. Following the literature, we call that method a focal method. Back to the chronology example, this is a code snippet of the test with zone test case, covering the with zone function implemented in Boolean chronology. Here, by inspection, we see that with zone is a focal method of this test case. Having seen the example, we're ready to define completable candidates, which will satisfy three properties: have siblings, have implementations, and are tested. We will illustrate the definition with an emoji example. Consider each of the emojis shown here as one sibling class. The first property we check is there are more than one sibling classes, as otherwise there will be no existing test case to serve as reference. Then, for the implementation property, we require a completable candidate that all sibling classes must have an implementation of the focal method. In this example, all emojis have an implementation of function drawFace. On the other hand, for partial completable candidate, we only require some sibling classes to have an implementation of the focal method. Here, the beer emoji clearly does not have drawFace implemented, but we could still generate the test cases covering drawFace for other emojis. Last but not least, we require at least one sibling class to have the focal method being tested. In the emoji example, the drawFace function implemented for the face with tears of joy is covered by unit tests, and thus it can serve as a reference to potentially generate test cases for other emojis. We investigated the efficacy of our approach by implementing it using the soot framework plus JCoco and applying it to a sample of 17 open source Java benchmarks. In all, 11 of the 17 benchmarks had some partial or completable candidates. We had a closer look at Joda-time and soot, representing high and low coverage extremes. For Joda-time, the untested methods that do exist tend to cluster around a small number of classes. That is, many of the PCC methods share the same superclass. Such clustering of untested methods suggests that Joda-time may be an especially suitable candidate for test generation. Soot, on the other hand, appears to be poorly tested. However, more than half of the untested methods are from generated code. In conclusion, the key insight is that PCCs could easily improve test coverage for lightly tested systems. Our future work will focus on generating test cases for the untested sibling functions using existing test cases as references. Thank you very much for listening.